Hi, I'm Mr. Neidhart, a math tutor for Wyzant. Today we're going to take a look at a question that a student sent in, and it wants us to solve and graph a system of inequalities. A system is when you have two or more equations or inequalities. In this case, you can see that we have two inequalities, and we're going to solve them one at a time. After we solve them both, we're going to head and graph them on one number line. Okay, you're going to see my face disappear as I'm going to share another screen as we can work this out. Let's try. So right now, we're going to take a look at solving the first inequality. We have to isolate our variable. That won't work. And we're going to subtract 2 from both sides. That gives us negative x is less than or equal to 3. But keep in mind, negative x is the same as negative 1x. So we have to further isolate to get x fully isolated. We get x less than or equal to negative 3. But wait, we had divided by a negative. And so it's really greater than or equal to. The direction of an inequality sign always reverses if you multiply or divide by a negative. Let's take a look at that second inequality. We have to start by isolating our variable again. So we're going to subtract 1 from both sides, giving us 2x is greater than or equal to negative 9. Further isolating, we're going to divide both sides by 2, and we get x greater than or equal to negative 4.5. We don't need to reverse the inequality sign this time because we divided by a positive. This is actually our full answer. With the addition of the single word and, x is greater than or equal to negative 3, and x is greater than or equal to negative 4.5. That means any single number that satisfies both of those conditions is in our solution set, our collection of answers. But we're going to graph this now, and we're going to graph it by taking a look at the number line. And we're not going to put 0 in the center of a number line. Sometimes you see that. We're going to put the two numbers that we want to focus on, and that would be negative 4.5 and negative 3. And for this particular problem, we're going to notice that this graph actually has 5 sections on it. How can it have 5 sections? We know that we have a left section, a center section, and a right section. The other 2 sections are the single numbers. Negative 4.5 I'm calling a section, and negative 3 I'm calling a section. So we're going to take a look at those 5 sections one at a time and decide if they should be filled in or shaded in on the graph. Let's take a look at this left section. I need to pick one number to represent everything that's less than negative 4.5. It's easier than testing an infinite number of numbers. We just need to test one of them. Negative 5 is left, negative 6 is left, negative 7, anything in there will work. So I'm going to test negative 6. And to test it, we substitute it into the answer of our inequality. And then we want to know, is negative 6 greater than or equal to negative 3? No, it's certainly not. Now, what we're actually testing to see if something is going to be shaded in, it says that we have to have and. It has to be true on the left part, and it has to be true on the right part. Both parts have to be true to get shaded. Well, since the left part failed, I don't even need to test the right part. Negative 6 will not get shaded because it failed already on one part. No point in going ahead and checking that other side. Negative 6 doesn't work. The second section of our graph is the single number negative 4.5. So we are going to substitute negative 4.5 in. Is negative 4.5 greater than or equal to negative 3? No, this is also false. And so negative 4.5 will not get shaded either. Again, I don't need to check the right half because the left inequality failed. We need to pick something here in the middle. Any number between negative 4.5 and negative 3 will work. I'll make it simple and make it a negative 4. Let's test negative 4 to see if it satisfies the left and right inequalities. So I'm going to test it over here. Negative 4 is greater than or equal to negative 3 by substituting. But that again is a false statement. Because it is false, we will not be shading the center section in. Our fourth section of graph, the single number negative 3. We're going to substitute that in to see if we have any better luck with this. Is negative 3 greater than or equal to negative 3? Yeah, because of that equal part, it's true. We have our first time true. We can't go ahead and shade yet until we test the other part. Remember, it has to be true for the left inequality and the right inequality. So I'm going to test -3 over here. Is -3 greater than or equal to -4.5? And it is. -3 is greater than, and because I have a true statement on both, I'm going to be able to shade in -3. So I take this point here, make it a circle, and say this point itself will be shaded in. We do a whole circle because it's kind of impossible to just shade in a single line. We're not sure how wide that line is. By circling the number that's labeled, like -3, that indicates that single point is shaded in. Well, we've tested 4 out of the 5 sections of the graph, and we need to test one more. That last section is all the way to the right, and I have to now pick one number to represent everything to the right. Anything that's greater than -3 can work. I could do -2 or -1 or 0. I could pick any number I want on the further right in the positives, like 500. I'll just pick +5, and that will represent that section on the right. So we're going to substitute in +5. Is 5 greater than or equal to -3? Yeah, that should be positive, or it should be obvious that a positive is always greater than or equal to a negative. And now we're going to test it again because we want both parts. It has to be and. Both parts have to be true. Is 5 greater than or equal to -4.5? That also is true. Because that is true in both parts, that means this right section of the graph will get shaded. And so what we do is we continue shading all the numbers to the right, but we want to show that that goes on forever, so we shade the arrow with it. Now we have 2 parts to this answer. One was the actual inequalities solved out, and we had 2 parts to that answer, that x was greater than or equal to -3, and x is greater than or equal to -4.5. And then we have the graph part. We were asked to solve and graph, and it is there, the number line with -3 shaded and everything to its right. The shading suggests that any number in the shaded area will satisfy both inequalities, not just here, but the original inequalities there. And that is all we need to know. We have solved that, and we are now finished with the problem. Hopefully that made sense of how to solve and graph an inequality system. Thank you for watching.